Hey guys, we are on lesson 5, identifying proportional and non-proportional relationships in graphs. This is page 41, of your workbook. And we start with an opening exercise that you probably can pause and just go ahead and do. It's review of the previous lessons, so you should be able to handle it. If you've already paused, we have Isaiah sold candy bars to help raise money for a scouting troop. The table shows the amount of candy sold compared to the money you received, and you're trying to see if it's proportional. So basically, same as prior, that you want to divide y divided by x and see if it's proportional. So you have 3 divided by 2, and does that equal 5 divided by 4? And does that equal 9 divided by 8? And does that equal 12 divided by 12? And they all have to be equal for them to be proportional. And so I could do this in a calculator if I'm not quite sure about it. 3 divided by 2 is going to be 1.5, right? And I could go through these, but I might just want to look here. 12 divided by 12 is 1. And if those two aren't equal, then no, there is not a constant of proportionality. It doesn't even matter what these are. They're not going to work anyway. So you say this is not proportional because there's not a constant. So therefore a proportion doesn't exist. There, okay? So today we look at graphs a lot, and this is a whole new area. Obviously we've looked at tables and we've looked at double number lines, and now if we go from a table to a graph, how does it look when you're comparing proportional relationships? It's kind of what we're looking at today. So you want to do you can pause and do the exploratory challenge. And so we see on this, using the ratio provided, create a table that shows money received is proportional. So it's the same kind of problem here, but now on this one, we are making it proportional to the number of candy bars sold. So if we have 3 and 2, and I don't know if they want us to use the numbers that were up here. You could use some of them. You might want to take a look at the x-axis here and see how far you can go up. This is the x-axis, so this is going to be candy bars sold. And then the y-axis is here, and this is money received. And so for 2 candy bars sold, you earn $3. And so you might want to put 1 in there even, right? If 3 divided by 2 was 1.5. So we have 1.5. 1 and 1.5 would be here. How about 4? If you sold 4 candy bars, and you could look at 2 and 3, so you could just double that for 6 because 6/4 equals 3/2, right? They're equivalent fractions. So this 6 divided by 4 would be 1.5, just like 3 divided by 2 is 1.5. So we have 4 and 6. And then we have, I don't know which other one we want to use. How about, maybe we want to do 10, just so we see where it's going to be up here. So if we sell 10 candy bars and we multiply, if we look at 10 and we multiply 10 times 1.5, we can get 15 here, right? For money received. Oh shoot, I was wondering if it was going to go that high. I didn't really think about that. Okay, let's go to 8. How about 8? So if we go to 8, and then we could, since 4 is there, this is 8, we could double that. That would be 12, because that's going to be equivalent fraction. 12 divided by 8 is 1.5. So it's hard to see from here. I think that's right. 8 and 12. All right. So what we see here is the points that we plotted. And if you had different points, that's fine. Whatever, it doesn't have to be the same if you had 6 candy bars and plotted those points, because those points still exist. And then what you can do is connect the points with some sort of straight edge. I don't have a ruler right handy with me, but I do have workbooks. And this is where pencils come in handy. Not bad. Okay. So what we see here is that every point on this might exist, except for these are candy bars. So we're not going to have a quarter of a candy bar in here, but that's okay. I just want to make sure that you see that we do have a straight line, and it does go through this point right here, 0, 0. So that might be significant as we go on. This is a proportional relationship. It graphed a straight line that went through the origin, 0, 0. This is called the origin, the beginning. Okay? All right, so let's go on. The next one is actually make a little bit of noise here, rip it out, otherwise it's not going to work very well. So characteristics of graphs of proportional relationships. We have a line. I keep saying straight line, but a line, the definition of a line is that it's going to be straight. And starts or goes through 0, 0, which is the origin. Okay, so we're going to graph for example 2. We graph the points here and we see what happens. And then for example 3, we graph and the points here and we see what happens and we answer the questions. Okay? I'm going to stop this video and then, because I'm having some issues with the clarity of it, and I'll continue on the next one. We'll go over the answers.